How does the Radon Sniffer work, and some tips on how to use it. The information in this video isn't needed to be able to use the instrument, but it helps some people if they understand the theory of how it works. All you need to know to use the instrument is to start by turning the sniffer on in clean air. Begin to do measurements in areas you expect to be low radon, and try to work your way from low to high, making sure not to turn off the sniffer in between measurements. Don't expose the sniffer to high levels for unnecessarily long, and let the sniffer run in clean air at the end of the day. That's the practical takeaway. Now, we'll get into why. The CT007-R uses an internal pump to draw air through a scintillation cell. Before air is drawn into the scintillation cell, any radon progeny in the air is removed by a filter. As radon decays inside the cell, the alpha particle emitted hits the wall of the cell, which is coated with scintillation powder, and emits a flash of light. The photomultiplier converts the light into an electronic pulse, which is then counted. The difficulty with using this principle for measuring radon is that the product of radon decay is also radioactive. The radon progeny tends to play out or stick to the side of the scintillation cell. The higher the radon concentration and the longer the exposure time, the more decay product gets stuck to the wall. The radon progeny continues to emit alpha particles, even after there is no longer radon in the cell. It takes about 3 hours for radon progeny to decay. In other words, unless one can determine the fractions of the pulses that are due to radon progeny, the time resolution will be quite poor, about 3 hours. The radon sniffer calculates how much radon progeny is stuck in the cell at any time, and can subtract that from the total number of counts. You then get a real-time measurement of the radon concentration in the air being sampled. However, there are some caveats to the previous statement. The calculation only works as long as the sniffer is on. So, turn it on in the morning in clean air and leave it on until you're done all your measurements for the day. Then, let it run in clean air for about 10 minutes or so before you shut it off. The radon progeny will decay overnight, and you can start again in the morning. This background process is not perfect. If you expose the sniffer to hundreds of picocuries per liter, you will not be able to measure air with 10 picocuries per liter accurately. So, always do your ambient air measurements before you do your subslab measurements. The calculation that the sniffer uses assumes all radon is radon 222. In fact, if you sample subslab air, you will likely also get some radon 220, also known as thoron, which our calculation doesn't handle well. But if you work fast and don't expose the sniffer to a lot of radon for a long time, the radon decay products don't have time to accumulate and there isn't much correction required. Some mitigators have found success while sampling each hole for 90 seconds and then going on to the next one. The 90-second is a good number. It is enough time to get a few air changes in the cell and for the readings to stabilize without bringing up a lot of radon decay products. The half-life of radon decay products is short enough so that they decay away overnight. But if you leave radon gas in the cell by not properly flushing with clean air before shutting off the sniffer, that has a 4-day half-life. That doesn't disappear overnight. Plus, it will have created radon progeny all night long. The next morning you will see lots of counts and the sniffer won't be able to do its background subtraction properly because it assumes all counts at the beginning of the day are from the radon, not the radon decay products. So, let the sniffer run in clean air before shutting it off to flush out any radon, and turn it on in clean air the next time you use it to make sure the counts are still low.